Hi there. In this video we're looking at finding the volume of cylinders. Now just a quick reminder, a cylinder is very similar to a prism, except this front face, the cross section, is a circle or an ellipse or a semicircle or something with a curved edge. So the first thing we're going to look at is just a cylinder with a circle as this cross-sectional face. But again, you can do this for semicircles or ellipses or any other sort of shape with a curved surface. Because they are so similar to prisms, in terms of finding the volume, it's exactly the same. So we just work out the area of this front face, the area of the cross section, and we times it by the length of the cylinder. And that's all there is to it. So we'll look at a few examples, but our strategy is exactly the same as for prisms. Okay, so into our first example, so we've got a cylinder with a circular face, and remember the cross section that we're trying to find is the face that's been stretched. So the area that we're after is the area of this circle on top. Now, this one's a little bit trickier than the prisms because I think students generally struggle with finding the area of circles slightly more than with triangles and rectangles. Again, we can work through this, we can get there. So remember, the volume is the area times by the length. So we need to work out what the area of this circle is first. Now, the area of a circle, we should remember, is pi times by the radius squared. And in this question, we are actually given the radius very handily. From the centre to the edge of the circle is 4 centimetres. So the area is pi times by, well, if the radius is 4, we do 4 squared. Now 4 squared is 4 times 4, which is 16. So that gives me 16 times by pi. And if you want an approximation to that, if you grab your calculators, you can either use the pi button, which if you've got a Casio is shift and then the standard form button, or you can just do 16 times 3.14, which is approximately equal to 16, 3.14, which is 50.24. Good, so an exam question might ask you to give your answer in terms of pi. If it asks you to give your answer in terms of pi, this is the one you're going to use for your area here. If it wants you to give your answer to 1 or 2 decimal places, you're best to use this one. This one is slightly more accurate, but it's harder to intuit how big it is. So both of these have their place sort of in real life. But like I say, this one's slightly more accurate. This one's a bit easier to visualise. But let's go and find this volume now. So the volume is equal to, well, the area. I'm going to use 16 pi in this one, but in the next example, I'll use the approximation. We'll do it to a decimal. So the area is 16 pi, and I'm going to times that by the length of the cylinder, which is 8. I do that in green. That's not a 4. 8. Okay. So 16 pi times 8 is 128. 28 pi. So for this question, the volume is 128 pi. Again, you could approximate that. You could write that as a decimal by doing 128 times by 3.14, which would give you 401.9. So if it did ask for it to 1 decimal place, the answer would be, we'll write that down actually, 401.9 centimetres cubed. Depending on the context of the question, you might be able to give both, you might have to give one, but certainly if you're out in the real world, both of these will be correct. Okay, so let's have a look at this example now. So this one, slightly different again. We have a semicircular cross-section here rather than a full circle. But that shouldn't stop us. We're going to use exactly the same method, exactly the same strategy as before. So we're going to find the area of the cross-section, the area of this semicircle, and then we're going to times it by the length. Okay, so the area of this semicircle, well actually, let's draw this semicircle out just to make it a little bit clearer what we're trying to do, because it doesn't look like we've got any measurements on the face of it, whereas actually we do. They've just written it in a slightly different, a slightly trickier position. So I know that this length here is 10 centimetres. Now remember, the area of a circle is pi times by the radius squared. We've got to be really careful, and this again is a really common mistake. We're not given the radius of this semicircle. We're given the diameter, that's all the way across. So remember, this is the area of the full circle. What we'll do is, to get the area of the heart of a semicircle, we half that at the end, don't we? So I'm going to do a half times by pi times by the radius squared. Good. So the first thing we've got to work out is the radius. Now the radius from the middle to the edge is 5 centimetres. Now if the diameter is 10 centimetres, the radius is half of that, 5 centimetres. So if we had the full circle, and again another strategy we can use to work out parts of circles is to pretend we've got the full circle. So if we had the full circle, the area would be pi times by 5 squared, which would be 25 pi. But we've not got the full circle, we've actually only got half the circle. So the area here then is a half of this, so it's a half times 25 pi, which is 12.5 pi, or we can approximate that to 12.5 times 3.14, 15.64. So again, exact, approximate, it's useful to be able to do both. Okay, so we found the area of this semicircle. So our last step now is to work out the volume. So my volume is the area. In this one, I will do the approximation. So the volume is 15.64 times by the length, which is 6. Which again, if you type that into your calculator, gives me 93.84. I don't know why I'm holding that up, I probably can't see that. 93.84, and again, centimetres cubed. So exactly the same strategy, find the area of the cross section and times by the length. I'm sure you're getting tired of me saying that by now, but good. Okay, so last example now. So in this question, we're told the volume, and we have to work backwards to find out what the radius is. So with all of these work backwards problems, the method is the same. We need to think, how did the person writing this question arrive at this answer of 72 pi? So at home, just have a quick think. Can you think about what the strategies we're going to use? If you want to, again, with any of these questions, pause the video and have a go. Feel free. But how did the person writing this question arrive at an answer of 72 pi? Good. Okay, so they use the formula. The volume is equal to the area times by the length. Okay, so when they were working this question out, they knew what the length was. They knew that the length is 8. They didn't know what the area was, but then they got 72 pi as an answer. So what we can do is we can think, okay, they're working this question out. What answer must they have got for the area to make the area times by 8 equal to 72 pi? So again, we can work that out We work that out by doing the opposite of this times by 8, and we divide by 8. So if we divide both sides by 8, we get rid of this 8 over here, and that leaves us with the area is equal to 9 pi. Okay, we're getting there. So now we need to think, okay, the person that's working this question out, they did the volume is the area times by the length. For that to work, they must have got that the area was 9 pi. So now we think, okay, what math did they do to work out that the area was 9 pi? And this is where we can close on our r. So if remember, the area is pi times by the radius squared. And we know that when the writer of this question did this, they got an answer of 9 pi. So they got 9 pi is equal to pi times by r squared. Okay, now there's a little bit of simplification we can do here. We've got a pi on both sides of the equation, so what we can do, because everything's times, if we divide both sides by pi, then we're going to cancel these out, and that's going to make it a little bit easier. So we get 9 is equal to r squared. So now, how do we get rid of this squared? What's the opposite of squaring something? Correct, square root. So if we square root both sides, we get that the square root of 9 is 3 is equal to r. Now I'm sure some of you at home are screaming at me saying, well actually the square root of 9 could also be negative 3, but when we're dealing with lengths, generally speaking, we're not going to get negative lengths, so we're fairly safe to assume that actually the radius is the positive version of that 3. So to get an answer of 72 pi, this radius must have been 3 centimetres. Don't forget my units. There we go. Good, well done.